to get the standard deviation of a population, to get it for the entire population, it's fairly straightforward. We're going to hit equals, and we'll go to STDEV. Now, there's not a formula that's called standard deviation, but it's STDEV, and there's .P for population and .S for sample. We're just going to use .population for this class, and we're going to assume that we have all of the underlying data. So we're not going to use the .S. We will always use the .P. And we're going to get the standard deviation for the population without any drill down or anything like if. And that gives us a standard deviation of 11.38 years for the entire population. Now let's look at the standard deviation for the infected population. This one's going to be a little more complicated. And if you're not comfortable with Excel or familiar with it, just watch this a couple times. Feel free to email me and we can walk through it. But this one's going to be a little tricky because it's actually called an array formula and we're using an if statement. So we're going to do standard deviation.p and we're going to do an if. And we're going to look and say if they are infected equals yes. If column D equals yes, then we will get the standard deviation of column C. And I put that formula in, I hit enter, and you see a 0. That is because with an array formula, after you type it in up here, have the cursor blinking up here, and you'll type Ctrl, Shift, Enter. It puts those curly brackets next to it, and it processes it as an array function, and it's going to give us a standard deviation for the infected population of 4.62 years. Now let's copy that formula because we've just created it. Let's go to the infected no area, and we're going to overwrite this and say if they're not infected, what's our standard deviation? And we're going to again put the Control Shift Enter into here, and you should get a standard deviation for the not infected population of 13.54 years. And so this is interesting because if you just looked at the average, you would say there's no difference in age between infected or not infected. In fact, the entire population's average age is 41. If they're infected, it's 41. If they're not infected, it's 41. But standard deviation tells us that the infections are actually clustered around 41 years old. And we'll talk about the distribution rule, but this is showing one standard deviation, and 68% of this population is going to fall within one standard deviation above or below this mean. And so what this tells us is the infected population, there is something special about the age, and it is clustered around this mean, whereas the non-infected group, it's more variable. And this graphic shows a good example of that. These are 3 populations with the exact same mean. This is not the zombie data set. This is an image that I really like that demonstrates this. But it shows the average could be the same, but there is significantly more variability in this population versus this and then this one. But for the standard deviation, just plot these 3 and email me if you have any questions.